Let's make a start. My name is Dominic Binks. I'm one of the UK TinyML chapter committee. Today's talk is presenting the upcoming TinyML Cookbook and the next in-person activities for the UK group. Our speaker is Gian Marco, who also is part of the UK TinyML Meetup committee. TinyML Talks are sponsored by these wonderful companies: Aeon Devices, ARM, Deeplight, Edge Impulse, Emza Visual Sense, PhotoHub, Greenwaves Technology, Grovity Inc., HOTG, ImagineMob, Itemis, Clickertech, Latent AI, Maxim Integrated, which is part of Analog Devices, Micro AI, NXP, Prophecy, Qualcomm, Kixo, Reality AI, Renesas, Rexon, SAP, Seed, SenseML, Sony Semiconductor Solutions Corporation, ST Micro, Stream Analyze, SynSense, and Sentient. There's a big list of people there. What's happening next week? Very exciting, a big in-person event in the Bay Area, Hyatt Regency San Francisco Airport. It's the TinyML Summit. The last few have been online, obviously, like lots of things. This one is actually in person. If you can get there, I'd recommend it. I went a couple of years ago, the last one that was actually in person. The details are there. There's also a TinyML research symposium, which is attached to the thing, which is for research in the area of TinyML. So the TinyML Summit will be focused on both techniques and products for doing TinyML or ML on tiny devices, and the research symposium is obviously more geared towards academia. The next TinyML Trailblazer series, which is a series of conversations between Chris Rowan on the right and in this case Eric Pan, talking about people who've been doing TinyML for a while and have had experience and successes and probably failures too, and it'd be useful to listen to them to discover the things they got wrong, and so that you can avoid making those errors, as well as to hear about their successes. So Eric Pan is the founder of Seed Studio, and Chris Rowan is now part of Cisco, but was in a early success for TinyML. TinyML also has communities like the UK one, which is possibly how you saw this through the meetup groups. There's 43 groups over 34 countries with 8,500 members across them. If you're not a member and be interested in following things, the TinyML meetup groups get to see, I think, all of the online presentations, and increasingly now local ones will be starting to have in-person events, as we will be in the UK. There's also a TinyML community on LinkedIn, which has obviously got quite a lot of followers and quite a lot of members as well, where you can find more information about TinyML and follow what's happening. You can also subscribe to the TinyML YouTube channel. It's 347 videos. This covers many of these TinyML talks like this, but also the summits and things as well. So there's some quite academic and high level and high detailed talks, as well as some that are perhaps a little more straightforward and introductory in nature. Also, this talk will end up on there in the coming days. Well, I'll come back to that in a moment. The next TinyML talk is on Friday at 6 p.m. Pacific time. This is a father and daughter double act using TinyML to solve gas leak detection, which I think is a really interesting application, and goes to the heart, I think, of what TinyML is all about. It's about solving small problems with focused solutions in really clever ways. Our speaker, as I mentioned, is Gian Marco. He's the tech lead of the machine learning group in ARM, and responsible for the ARM compute library. Gian Marco has been involved with TinyML for a long time. He's worked on lots of different things in ARM, as you can see. And as I mentioned, he's also one of the committee members alongside myself and Alessandro and Neil Cooper of the TinyML UK group. So I've had lots of chances to speak to Gian Marco. It's one of those curious things with COVID. I've not actually met him in person yet, but hopefully we'll be putting that to right soon. Gian Marco, over to you.
Thanks a lot, Dominic. But well, for sure we'll meet, because we will have in-person activities in UK, so in Cambridge in particular. So thanks a lot again. So welcome everyone. And today I'm gonna present the next TinyML book that I just finished writing, which is TinyML Cookbook. But I'm also super happy to be here because, as mentioned also in the title, we're going to present the upcoming in-person activities planned for the TinyML UK group, in particular in the Cambridge area. So let me start from this slide. So this is I'm going to talk about the TinyML Cookbook that I've wrote, which is not available yet, but it will be released pretty soon, the 1st of April. Although it's available anyway in pre-order on Amazon and other places. So I want to start this talk explaining why I decided to write this book, TinyML Cookbook, and to explain why I like to start from the definition of TinyML. So TinyML, this is more or less the definition you can find on internet and other places, is a fast-growing field at the intersection of machine learning and embedded system to enable smart applications on extremely low-power devices. So you need, as we know, at least 3 ingredients to have a TinyML application. So you need the machine learning, we need an embedded device, and we need low power. So which means that the embedded device must be energy efficient to perform the machine learning computation. In the context of the book, these 3 terms refers to deep learning. So ML and deep learning will be used interchangeably. Embedded system or embedded device will be a microcontroller. So because all the projects will be developed on microcontrollers devices. And low power, since we are using microcontrollers, will be in the range of milliwatt or below. However, although there are 3 keywords in this sentence, there is also another word, which is intersection. And so why is intersection? Because TinyML exists if and only if machine learning and embedded system know each other at best. This is a field where machine learning needs to know the target device in order to deploy the application on the device, because if you don't know the target device, you cannot really run anything. On the other side, the embedded device needs to know the machine learning algorithms involved in order to expand the computational capabilities of this device and definitely unlock new use cases. So this is different from what we have seen on the server and on the smartphones, for instance. I have been lucky enough to work a time from the server, on the smartphone, and on microcontrollers. And what we have on microcontrollers is totally different from what we have, for instance, on the smartphone. I remember in 2015, probably, when we started deploying the first machine learning models on the smartphone, what was the key problem there? It was just about, let's say, performance, because you could run it anyway, any machine learning models on the smartphone, because you had enough memory to run it. Probably it wasn't the most efficient. That is, most of the effort was put on performance. Of course, now there are also other hardware IPs to run these machine learning workloads in the most efficient way, but definitely the key there was performance. What about microcontrollers? Well, definitely here is completely different. It's not just about performance, but also about model size. If you don't consider the model size, you will never be able to run any machine learning models on this device. But to explain why I decided to write this book, well, let's focus on this word, growing field. So the question is, since when? I don't know exactly what was the first machine learning applications on microcontrollers, but for sure, I can say that in 2013, I heard and deployed the machine learning applications on microcontrollers during the course at University of Pisa during the master degree. The course was about ambient intelligence, and the first lesson, slide of that course was If Words Could Talk. So the course was about the elements behind pervasive computing, so machine learning, sensors, low power communication protocols, and embedded devices, with the aim to allow humans to interact with the environment in a natural way. In short, what we have now with the smart assistant, we use our voice, but this is more just a voice, also user habits. For instance, turning on the light when is needed without asking anything. But I don't want to explain what ambient intelligence is. Here, I'm more interested in say, well, already in 2013, from the studies I did at University of Pisa, there were the concept of machine learning and embedded devices. But it wasn't the era of TinyML yet. Why? But because if I look at the past, it wasn't that easy to have machine learning embedded devices. And it was really hard because you had to be an expert of machine learning first, but you also had to be an expert of embedded system because it wasn't really straightforward to deploy machine applications on microcontrollers. So what we have now, we have a completely different story for the machine learning and the microcontroller side. On the machine learning side, we have definitely, compared to at least 2013, more sophisticated neural networks architectures. We also have frameworks which are free, open source, and really easy to use on Python. So with few lines of code, we can train and have a model to classify images or doing object detection. Furthermore, if you are not machine learning expert, well, there are also end-to-end tools that can make the machine learning design straightforward. In some cases, well, these tools will also help us to learn how to design machine learning architecture because they do everything for us. They suggest us what the architecture we could use for that specific problem. But also the microcontroller world, so a change, a transformation, and mainly on the programmability side, because now microcontrollers are really easy to be programmed because the IDE, for instance, offers a plug and play experience. So you can take a microcontroller, connect with a USB cable to your laptop, and you open the web browser, write few lines of code, and you can turn on and off the LED or interact with other devices with zero effort. Furthermore, that code is also portable on other platforms, so you don't have to change anything. That wasn't the case in 2013, or at least it was the beginning of what we have now for sure. But the other important thing for TinyML is the fact that now we have a lot more of low-cost sensors and microcontroller boards to experiment or build products with. There are microcontroller boards, really powerful, but also with sensors that we can use for building products like powerful cameras, microphone, or other accelerometer or other sensors for instance, for detecting the gas or gas leak and so on. So this is for now we have TinyML because this machine learning on embedded device with low power is for everyone. Everyone can do it. And the motivation is this. The book wants to demonstrate that TinyML is for everyone now, even for those with no little familiarity with embedded programming. That is the aim of the book. And as you can imagine, from the motivation, you can also understand what is the target audience. The target audience are primarily machine learning developers or engineers with machine learning background interested in developing machine learning applications on a microcontrollers with practical examples. Because this is a practical book which will teach through examples how to do the things, but it's not just how to do the things, it's also the why we are doing these things in this way. But it's not just for ML developers. Of course, also embedded developers can benefit from the book, but they need at least to have a basic understanding of machine learning because the book assumes you have, let's say, a bit of knowledge of what TensorFlow is, for instance, or you have a bit of knowledge of how the architecture is composed in a deep learning scenario, for instance. So concerning the target platforms, the book will use primarily two microcontroller boards to present two different development scenarios. And say primarily because there are also virtual platforms used to deploy machine learning applications, but primarily the Arduino Nano 33BLE Sense board and the Raspberry Pi Pico will be used. And if you ask me, why did you use these boards? The reason is simple. So I wanted to present the two different development scenarios as written here. So the Arduino Nano is a complete platform. You have the microcontroller, but also you have a bunch of sensors. So you don't need most of the time to connect any external components. You can take the board, connect to your laptop, and use the onboard sensors to build your TinyML project. The Raspberry Pi Pico represents the TinyML scenario where you have the microcontroller, which is definitely extremely powerful, but you don't have sensors. What could we do? What can we do? So, and this platform will be used to explain how to connect sensors or how to interact or interface the microcontroller with the external components. Also simple LEDs, because this is it. TinyML is not just machine learning, it's also embedded development, but you don't have to be an expert to use it. And the book wants to demonstrate this through these two platforms. So what you will learn with the book. So the book has chapters, and the chapters are projects made of recipes. And the things you will learn are the following. So the relevant microcontroller programming fundamentals for TinyML, and why this is important. Well, if you have a machine learning background, but you don't know anything about microcontrollers, probably your first step is, okay, let me learn how to program microcontroller. But the question is, do I really need to know everything for TinyML? So that is the reason the book wants to at least shows only the fundamentals or the basic elements that you need for TinyML. For example, explaining what is the difference between energy and power in practical terms. Also to explain, for instance, how to connect batteries to microcontroller to build the battery power application, but also to explain why microcontrollers exist in the first place and why have been designed in this way. So explaining all of these aspects will help the reader also to understand what are the use cases that we are targeting with microcontrollers in particular. The other thing important that you will learn, use real-world sensors. For instance, you will learn how to interface with microphone, camera, accelerometer. You will use these sensors practically. So for instance, you will build also electronic circuits in some cases. In other cases, you will use the onboard sensors that you may have on the Arduino Nano 33BLE board. And this will be the opportunity to, yes, to play with these sensors, but also learn how to acquire the sensors data. This is a machine learning problem. So data is everything, is what it makes or breaks your application. And sometimes you will have to use a sensor which is not really, where you don't have, let's say, a public data set available. So you have to acquire this data somehow. And so the book will help you to understand what are the protocols that you may use, how to interface with these sensors, and so on. Run machine learning on microcontrollers. Well, this is the topic of the book, definitely. So we want to learn how to run machine learning on microcontrollers, but it's not just through a single tool, but it's through different tools that you may have, we have at the moment in the TinyML ecosystem. The book is a snapshot of what we have now. It's not everything. There are a lot of very cool and interesting products. So it's just a snapshot. And this in particular case, for running machine learning microcontrollers, I will be presenting TensorFlow Lite for microcontrollers, Gene Pulse, TVM and micro TVM, and Zephyr OS, for instance, for showing how to use the virtual platforms as well. Implement an application that responds to human voice and gestures. Well, these are projects around definitely the microphone and the accelerometer, with the aim to teach how to design a machine learning model for this kind of scenario, but also explain how to deploy the application on the target device. This will be also an opportunity not just to explain, as I said, how to do the things, but also the why we are doing the things, and present challenge that you may face. I can give a very simple example, and that we'll see later on when I will show you an example presented in the book. For gesture recognition, well, we want to recognize the gestures, but most of the time we need to filter out redundant classification results. So there will be a recipe to explain what algorithm, for instance, we can use to filter out the redundant classification and have a robust output from the machine learning model. Leverage transfer learning to classify indoor environments. There will be a dedicated chapter for indoor scene classification. And honestly, this is the chapter I like mostly, along with another one, but I like mostly because apart from the machine learning problem, there is another problem, which is the input preparation, the input model preparation. Here, we are going to have a camera. We are going to have the model. However, the camera will have an image resolution and color format, which is different from what we expect in the machine learning model. So we will need to implement an image processing pipeline. If you consider whatever application, let's say for a smartphone or on a desktop machine, well, that's trivial. You can use a lot of different libraries and we can run each operation sequentially, and that's it. On microcontrollers, well, in some cases, this is not enough. And you need to exploit techniques to reduce at minimum the memory pressure, in particular when you deal with images. So here there will be an example explaining how to take the image frame, do the cropping, applying the color format transformation, do the image bilinear interpolation, so scaling, normalizing, and feeding the input model in the most memory efficient, which means fusing all the elements together. The other thing you will learn is the design of tiny models. This is the other chapter I really enjoyed writing. In the chapter I wanted to present, in the book I wanted to present a chapter to explain basic concepts to deploy or to design small and tiny deep learning algorithms for tiny microcontrollers. And so the idea was to take in consideration CIFAR 10 dataset, so to classify 10 different classes. And this chapter explains some methodologies to learn or to infer the memory utilization in terms of program and data memory, for instance, and also to what techniques we can adopt to keep a minimum the memory utilization. And so we will there will be an explanation of these techniques and also the reason behind it. For instance, the explanation of how to estimate the number of multiply accumulates operations to perform by each operation in order to estimate how fast it can be at that model. And in the end, which will be the last part of the book, I'm gonna be presenting a software tool which is still under heavy development, but it's gonna be promising, which is a deep learning technology through TVM, micro TVM, with the aim to run a machine learning solution on a virtual ARM Ethos U55 macro NPU. So this is something we're going to have in the future. So dedicated IP for machine learning to unlock new use cases, because we will have more computational capabilities, but keeping a minimum the power consumption. So before jumping to the chapter 6, Dominic, are there any questions?
Yeah, there's a couple. I think they probably are worth asking now, since you asked. One question would be, can the book be useful for students or universities, or might it be complicated for them?
Absolutely, it can be useful. Of course, they will need to have a basic understanding of machine learning to, of course, be able to build all the projects presented in the book. But this is just a basic machine learning, so you don't have to be an expert of ML or deep learning. So, for instance, knowing what TensorFlow is, how to use it, this should be enough to learn how to deploy the TinyML applications. But definitely, yes.
A related question is, are there any plans to develop slides related to the material in the book?
Slides, okay, definitely the answer is yes, because tomorrow I will be officially announce the book in another event where I have prepared the slides presenting all the chapters in a more detailed format. For instance, I will explain what this chapter, what you will learn in that chapter, what you will do in that chapter to learn these things, because it's a learning journey, the book. And so any chapter has a learning section, of course, and tomorrow we'll explain in more details these aspects. I have provided the links to the event in a separate slide that I'm going to show later.
Okay, cool. And I think this is another really good question, which is, what does your book cover that the TinyML machine learning with TensorFlow Lite book covers, if you see what I mean? Can you try and sort of tease apart what the differences are, what they, maybe what their different remit says?
Okay, well, definitely is. I also had a chat with Dan, which is actually the author of the previous book, along with Pete Warden, is complementary. This is not something that is going to replace. You need both to be to have a good understanding of TinyML. Why is complementary? Because the first time the TinyML book was definitely brilliant to explain, in particular to the embedded developers, what machine learning is on microcontrollers, and it gives you a comprehensive overview of TensorFlow Lite for microcontrollers. The TinyML Cookbook is actually more oriented to people with machine learning background, but with no embedded programming experience. Furthermore, it is, let's say, 2 years later, and it covers tools not covered in that book, like edge impulse, for instance, and micro TVM.
Yeah. Okay. That's it.
Cool. Okay, so what we're going to do here now, I'm going to present a chapter to explain more or less the structure of the book. I'm going to consider chapter number 6, where the project is about building a gesture recognition interface for you to play back with Raspberry Pi, Pico, and Edge Impulse. In short, the goal of this chapter is to build a remote that you can control with your gestures to play, mute, or change your video songs with the Raspberry Pi Pico. And let me go to this. Let me change screen. Can you still see my screen, right?
Yes, we can.
Perfect. Okay, this is chapter number 6. So, and I'm showing a part of the book. So, and I'm in this section, I'm gonna give you, I'm gonna present the structure of the chapter that basically is consistent throughout the book. So the chapter has an introduction to the problem, so explaining what gesture recognition is and what we're going to do in this chapter. In this particular case, we're going to use an accelerometer with machine learning to recognize hand gestures with the Raspberry Pi Pico. So in the introduction will be also the a part presenting what you will learn with this chapter. For instance, in this case, you will learn to develop an end-to-end gesture recognition application with Edge Impulse for Raspberry Pi Pico, but it's not everything. You will also learn how to use this serial peripheral to acquire data from the accelerometer. Also writing a multi-threading program with an ARM embedded OS. Why multi-threading programming? So we have a single core, but we will need to perform 2 tasks at least, right? At the same time, we need to acquire the data and also run the machine learning model. So this chapter will be an opportunity to learn how to write a multi-threaded programming to perform these two tasks concurrently. And as I mentioned earlier, this chapter will be also an opportunity to learn how to filter out redundant classification results during the model inference, because you run the model inference with a small step. So you will have redundant classification results, but you want to be really accurate. So this means you need an algorithm to return the classification results only when you are sure that is the gesture that you it is the gesture you want to recognize. Before jumping to the technical requirements, there is a list of recipes presented in the chapter, because the chapter is a project made of different recipes, and each recipe has a list of instructions to follow to complete. In this case, the first recipe will be about the interface with the accelerometer, with the inertial sensor used for this project. The second recipe will be about how to acquire accelerometer data with the serial peripheral I mentioned earlier. The third recipe will be about building the data set with Edge Impulse. So we will use Edge Impulse to read the data transmitted over serial to build a data set and store it in the Edge Impulse framework. We will design and train the machine learning model, and trust me, it's going to be a really tiny model using a feature extraction algorithm, and explaining why that feature extraction algorithm works well for this kind of problem. Performing a like classification with Edge Impulse. And this is a cool feature I really like, for instance, because sometimes you have a model, you want to test it on the device, but before deploying it, maybe you can, the live classification provided by Edge Impulse is a nice tool to actually test the model before deployment, which is really cool and really find it useful. The other 2 recipes will be about the gesture recognition application on Raspberry Pi Pico using the ARM embedded OS for the multi-threading programming. And in the end, a touchless interface with Python. So we will use Python to interface with the YouTube playback. So in short, how to play, mute, unmute, change the song or video, and so on. After this introduction, there will be the technical requirements. So all the requirements that you need to complete this project, and of course the source code. The source code is available on GitHub, which is under and all the source code is under MIT license, a permissive MIT license. So you can enter the folder. The H file will have a number as a prefix, which will be, in short, the number of the recipe of that project. Let me go back to the book. So this is more or less the introduction section. Let me take in consideration just the first recipe, just to explain how it's structured the recipe. So of course there is a title, an introduction to the recipe problem, the link to the file to consider for that specific recipe. once after the introduction, there is a getting ready section. The getting ready section contains everything you need to know prior to implementation. And in some cases, it's not just what you need to know, but also explaining why we do the things in this way. For instance, in this particular case, I introduced the inertial sensor, the MPU 6050 from TDK, and also present the serial peripheral use or serial protocol using this in this particular case, explain how it works in order to reuse the recipe in your personal projects, because you may have other projects, and this preview may help you to interface with other sensors as well. And once we have, after the getting ready section, follows the how to do it section. So after that, you should know more or less how to do it. And this will be a sequence of instruction to complete the recipe with images. So we'll have images like this to explain where to put the elements on the breadboard, how to connect the elements to the wires between the microcontroller and the component, in this case, the accelerometer or the inertial sensor, a diagram explaining how to do the wiring, and also the part concerning the programming aspect with comments. So as I said, it's not just the how to do the things, but also explaining why we're doing things. And that's it. And after that, well, we proceed to the next recipe. But this is more or less the introduction, getting ready, and the how to do section to explain how to do the things. Let me go back to the before going back to the slides. Dominic, any questions?
There's no questions at the moment, Gian Marco.
Okay. Okay, so if there are no questions, I can go to the slide again. And before completing this this book presentation, as I said, also tomorrow will be the official book release. I want to thank these companies that helped me a lot in this journey. Definitely Arduino, because for the collaboration we had for instance, for the chapter number 5, interfacing with the camera, ARM, in particular the TVM team, to shape the last chapter of that book. Edge Impulse for the support given for implementing the projects using their tool. Pact, well, Pact is the publisher, and I need to thank them because they believe in this project. When I shared the idea to write this project, they were definitely happy, and they are very supportive. So that is the reason I need to thank them. The Raspberry Pi as well for their support, but definitely I need to thank the TinyML Foundation and you, the TinyML ecosystem, because what we have in the book is actually comes from the presentation that we had in the last couple of years here for the TinyML with the TinyML Foundation. So this is your work; these are your tools, and the book wants just to provide a snapshot to help other people joining this revolution of machine learning on microcontrollers. So these are the next events for the official book release. Tomorrow, there will be the official book release hosted by Newton AI. Here there is the registration link. There will be also a raffle session at the end to give away a free copy of the book in case you're interested. It will be the same for the other session. I will have the 20th of April, hosted in this case by Edge Impulse. In both events, Massimo Banzi will be with us, but in the Edge Impulse event will be also even from the Raspberry Pi. So it's going to be super cool. And honestly, we were super excited because I don't want to say, but when I was young, definitely I wanted to experiment on Arduino Raspberry Pi, and being in this event with them is gonna make me probably cry. No, probably not cry, but super happy for sure. And that's it for the book. Let's go to the the part that we want to know, the next in-person activities. So, Dominic, do you want to present the first upcoming event?
Yeah, so this is in a couple of weeks' time. It's at the Makerspace in Cambridge. If you don't know where that is, then if you get in touch with TinyML, we'll get the messages through. It's on a little road just by the river, and it's at 6 p.m. And it's Alessandro, who is one of the other committee members. He's actually lives in Italy, but he's going to be in Cambridge then, so this is a great opportunity to do something. And we're going to sort of it'll be a little bit play by ear, but we're going to talk about doing machine learning TinyML applications in the real world. My background is that I work for a company called Audio Analytic, and we do sound recognition. And talking as Gian Marco was, when I first arrived at Audio Analytic in 2013, I was introduced to a board and told there's a machine learning model running on this microcontroller, and I hadn't really registered that was something slightly unusual, but it turns out that was something slightly unusual, and so we've been working sort of along the lines of embedded systems, more or less, well, since I joined the company. And Alessandro has been doing this stuff as well for a long time. He works for Edge Impulse. So we're going to sort of talk about perhaps a couple of different views on doing TinyML in the real world, and some of the challenges, some of the great opportunities there are to do that. It's open to anyone. I think there's still a discussion that's ongoing about whether we're going to try and organize some pizza or something like that. I'm not sure whether we will be able to do that or whether we won't. But if you are available, if you're in the Cambridge area or can get to Cambridge easily, we'd love to see you. We'd love to meet some of the people that we have not been able to meet for 2 years.
Definitely super. Unfortunately, I won't be there, but I really hope we will have other sessions like this in the near future. And definitely this event is open to anyone. You don't have to be a member, you have just to come and enjoy the TinyML practical session there.
I think you have to. I think you do have to sign up via there, because it's the Makespace that actually are doing the registration. So I think you need to sign up with them. But yeah, otherwise there's no fee or anything like that. Just turn up.
And the other event plan, which is still a work in progress, we know the location, which is the Raspberry Pi store. So it's going to be the 27th of April at 5:30, probably. We are still not sure about the format. It could be a panel, it could be a presentation, hands-on session. So of course, we will keep you posted on this next event for the end of April. Super cool. It will be a Grand Arcade in Cambridge. So looking forward to it, honestly.
I think also is it Alistair Allen, isn't it, that actually spoke at one of our TinyML meetups of a couple of months back. I'm pretty confident he's going to be there. So if any of, and that clearly did garner quite a lot of interest, that particular talk, and there was quite a lot of challenging information and material. So if you want to come and have a chat to him, I'm sure he'll be around and happy to talk, as well as you will be at that one, won't you? Alessandro unfortunately won't be at that one. I might even see if I can drag Neil along to something, but he works in marketing, so he doesn't really understand this stuff.
Cool. And that's it for today.
So you should receive a poll. If you can answer the poll, that would be helpful to us. And I'll continue on. So we just want to say thank you to all our strategic partners. I listed them all earlier. There's a list of them for you to see. We'd also like to thank the executive strategic partners. They are Arm. Arm don't really need any introduction, but they've got a lot of work going on, obviously, in TinyML, in the ML space, as well as many other areas. Edge Impulse, Gian Marco mentioned them, the leading edge ML platform. Qualcomm advancing AI research to make efficient AI ubiquitous. Sentient end-to-end deep learning solutions for TinyML and Edge AI. Our platinum strategic partners, words are failing me today. DeepLight, fastest video analytics solutions on ARM CPUs. Clicker Tech Global IoT Solutions. Reality.ai, pre-built Edge AI sensing modules plus tool to build your own. Renesas, who are a microcontroller microprocessor manufacturer. Our gold strategic partners, PhotoHub, Maxim Integrated, Latent AI, Adaptive AI for the intelligent edge, Micro AI, NXP, Seed, SensiML, ST Micro, SynSense. And those are our strategic, silver strategic partners. Just a reminder, the next TinyML talk will be on Friday at 6 a.m. Pacific time. If you're west of or the east of the Atlantic, this might be quite painful. I mentioned the gas leak detection. And that's it. Just one more thing, just before we close. So, Olga, please don't stop the recording. One question has come up, and I just think it'd be good to get an answer for it since we've still got time. What kind of ML tasks that the TinyML book tackle besides classification of CFAR 10?
Okay, in terms of classification tasks, so for sure the gesture recognition, which is another classification task. For sure, there is the an audio classification task. So in short, the applications will be around the 3B sensors. So vision. So in short, the microphone, the camera, and the accelerometer will be all on the image on the classification side of things. But mainly behind these sensors, plus the CFAR 10.
Excellent, thank you. I think we're done.
Okay, so thanks a lot.
Thanks for coming. Thanks for your time, Gian Marco. It was great to have you.
Thanks a lot.